My name is Torsten Hoefler. I'm one of the two paper co-chairs at the PASC conference. The other one is sitting here, David Keys. I have the big pleasure to give you this slightly longer version of the presentation of this morning. So this will be about 10 minutes, describing how this whole paper selection process came into place, how we did it, why we did it, and what we are trying to do for the future, and what we are trying to essentially establish here at the PASC 16 conference, and of course going into the next year's version 17, and then of course 18 and 20 until 20. Okay, so the major idea of the PASC conference, as you probably know, is to bridge communities. So to try to really offer a venue for attendees ranging from life sciences to geosciences to computer science that have very different backgrounds, but there's one thing that unites them all, and this one thing is really that we are all using computers in one way or another to solve scientific computing problems. So this is the essence of the PASC conference with the large diversity of 6 different fields. So one of the problems, or one of the facts that we have to mention is that we have different publication procedures in these fields, and this is a little bit tricky because now if you want to offer a single venue across all these different fields, what kind of publication scheme do you use? There's one scheme that is often used in the natural sciences and engineering sciences, which is the journal scheme. So journals are typically considered to contain very mature publications with a thorough review process, and usually expert reviews specialized to the particular paper submissions. However, the downside here is that it could be a rather long process, and really a journal doesn't have a dissemination component. Of course, you could have conferences that act as this dissemination component, but this is not necessarily as organized as in other fields. For example, in computer science, it's kind of the opposite here. So in computer science, due to the pressure and also the youth of the field in general, we are mostly publishing in top-class conferences, which are often valued higher than top-class journals in the field. So the reason for this is because computer science is a rapidly developing field, and the turnaround in conferences is usually much faster, so usually half turnaround time than journals. Of course, I'm grossly simplifying here, so we can have various discussions that will lead to differences, but I'm just providing the average, essentially. And then, of course, this contains a dissemination at the conference. So it's very useful if I have a conference publication. This means I will go to a conference and will be able to talk to my peers like we do here at the PASC conference. However, the downside is often that the committee for this particular conference is pre-selected. So this means if I'm sending a paper that is slightly out of scope for this conference, for example, a computer science conference, and I'm sending a paper that talks about life sciences in the context of computer science. So for example, I'm developing a new FPGA system for Borrows-Wheeler transform for life sciences, then this may not have the most appropriate reviewers in the pre-selected committee of this particular conference. So this is one issue that's much better in the journal process. And I personally believe that the rebuttal system that we have in many conferences is a total waste of time, because rebuttals really, you write a letter to the committee to rebut the reviews, but this doesn't really improve your paper. While in the journal review process, you have a revision, and the revision really directly improves your paper and allows you to rebut the reviewer's comments at the same time. So there's really no time overhead. And so looking at these two systems, two publishing systems in natural sciences, engineering sciences, and computer science, we decided to come up with a hybrid scheme for this particular iteration of the PASC conference, and that is the PASC Papers track. So this is really what we've done this year. So we took the best of both worlds of these two, the green things here basically, and merged them into a single publication process that we call the PASC publication process, and we will see how successful this is. So, and fortunately, as I mentioned, I've not been doing this alone, so much of the work has actually been shouldered by David Keys and Tim Robinson, who was wonderful administrative support, as well as the proceedings chair, and of course, not to forget our area editors. So this means we had one expert from each of the 6 fields that the PASC conference series is about to basically assign these papers that come in on this particular track, on this particular scientific area, to the best experts in the field. So this is how we operate. So we as general chairs, as you can see, David Keys, expert in mathematics and computer science, and me, only computer science without the mathematics part. So we are not really imposing our view on the committee, but we take we really bank on our area chairs to represent these communities. And this will, of course, stay like this in the future. So for this paper process, we're really basing on there are four central pillars that are different from journals as well as from conferences today. So the first pillar is that we don't have a pre-selected committee. This is extremely important. So the committee is really established, the review committee is really established on the fly, so to say. So which means that every paper is investigated by the area chair, and then the area chair finds the most appropriate reviewers for that particular paper. So this really gets us a higher expertise in the reviewing process. So there's no pre-selected set. So second is that we in fact have a short revision process, which means that we don't do rebuttals as in conferences, but we really do a revision like in a journal, which gives the authors the chance to improve their paper based on the first round reviewer comments and submit a new version. And even if it's rejected in the second stage, it will then be better than before. So it's not a waste of time as in the rebuttals. If it's rejected, your rebuttal is totally nonsensical, or it may even be nonsensical if you're accepted. So this is more closer to a journal. But of course, since we are at a somehow conference-like publishing cycle, this means there is less time for such a revision, and you have a little bit of pressure on the authors to actually get this done. So this year we only had 2 weeks, and I have to say that I was very surprised that all the papers who made it into that round submitted substantial revisions. Some of them completely rewrote the paper, that completely changed the review at the end. It was very, very interesting to observe. The third pillar is that it's a fully double-blind process, which is now getting more and more common in the conference side, not so common on the journal side so far. But this really means that the chairs, so myself as well as the reviewers, did not know who the authors are. So the reason is why we do this is to avoid an institutional as well as a name-based author bias. So if a particular person is famous in a field, we cannot reject his or her paper. And this, I think this is a good idea because we get really a much wider and much fairer review process and a wider participation in the system. And then the last pillar of this review process is that we have suggested expert reviewers. And this means, since we have a 2-stage review cycle, we really asked the reviewers in stage number 1 to suggest experts to tell us who would be the person in the field to review that particular paper. And this was an incredible success, I would say, because most of these expert reviewers agreed to do this. And in fact, some of them changed the reviews substantially, but I'll have a slide on this in a couple of minutes. Okay, so this is a slide we've seen previously. So this is the submission overview. We had 44 submissions at stage 1. So for a first iteration of a conference, actually a pretty good result. The authors come from various different nations. Interestingly, we were somewhat Switzerland-centric, of course, but we had most submissions from the United States, or most authors from the United States. We had a very high number of submissions in math and computer science, and the other fields were more or less balanced. And here you can see a wordle of the abstract, the most common words in the abstract. We can see data, parallel performance, code, problem. So really what PASC is about, right? Parallel performance, scientific computing, and of course, large scale and data. So here we see the reviews, and the most common word here is work, right? As you can see. So this is the a wordle of all the reviews. But in general, these reviews are rather positive, as you can see here. You see some negative words as well, but usually it was a constructive review process. So we got about 182 reviews in total. We had 60,000 words total, so basically a multi-volume book. And out of these 44, we only accepted 12 papers at the end. And we had a physical program committee meeting where we discussed each paper. So we had a full-day meeting where each of the submissions was discussed for extended periods of time sometimes, and we actually got even additional reviews for some of them. The distribution of authors in terms of countries is basically the same in the accepted papers as it was for the submitted papers. So that's also a good sign. So there was no bias towards or against a certain population. So this selection is very important. It's really purely based on scientific excellence. We did not look at trying to balance across the areas or something like this. We took the best papers, period. No question. Some areas vanished in this process. This is what we have to admit. But this just happens if you focus on scientific quality. So we had this 2-stage review process, right, as I mentioned. 23 papers went into stage 2. They made all revisions. They had a full review after the revision process. And as I mentioned, these expert reviews, we had this face-to-face meeting. We discussed each paper, as I mentioned before. And basically, we asked for each paper, we asked these 3 key questions, right? So what did you learn while reading the paper, which is really a way to assess the quality and the novelty of the paper? How many people would attend the talk is really about the relevance, and would I recommend my colleagues to read it? And actually, asking these questions sometimes changes the reviews and the answers quite substantially, because there are these papers that you just read and you think, oh, well, they're actually nice, they're not too bad, but then you have problems asking and answering any of these questions. Especially the first one often leads to changing an opinion on a paper. So, and then we had, of course, a committee discussion, and our mantra at the end was never go against an expert, right? Unfortunately, we didn't have to do this, not even discussing it. So, and now discussing the expert reviews, as I mentioned, these expert reviews were quite substantial and quite a big help, because usually these experts are the experts in their field, and very often it happened that we, in fact, got the author of the software that was used, or the first author of the method that was used in this particular in this particular paper to review that paper, and that was great. And I have to really thank David Keyes, my co-chair, for making this possible due to his great connections to getting all these people lined up to make these reviews at the end. So it was very interesting. All of these 23 submissions, they had expert reviews, and in fact, they changed. Sometimes towards the positive and sometimes towards the negative, the decision in a substantial way. So we, in fact, did a study how these expert reviews turned out, and they turned out to be rather positive. So I have a quick side note here. What we realized during the process, or what I realized during the process, is that unfortunately the performance reporting in our community is rather suboptimal, in the sense that we often see graphs like this. So if you look at most of the papers, you will see graphs like this, and then you kind of pretend, this is a graph from one of my papers, so I can take it and smash it. That you kind of pretend that performance is deterministic and it's all great, so I have a point here, look at this, great. And this graph has so many problems that I don't even have time to describe all the problems, but it's a relative speed-up plot, which is silly to begin with, and then it has no variance whatsoever. But in fact, in reality, we see more like this, and more something like this, where we have the distribution of the completion times. So if we may repeat the experiment 15 times, we will actually get 15 different completion times. And of course, what we do is report the best one, right? And then the others down here, it's 61 teraflop, we totally forget in usual. And this is, by the way, this is a top 500 run on the Pitts-Stein system. Of course, if you look at the, not a full-scale run, but if you look at the top 500 number, you will see this number. But in fact, the median is substantially lower, the mean is even lower, and the worst case is very low. Right? So this is something we need to consider when we report experiments. Unfortunately, we didn't do this. Many authors didn't do this. And it even gets worse if you have a distribution like this, where the median and the mean basically have absolutely no meaning because you can never get them. And so this is something that we generally observe, that we should try to push the community to have better performance reporting a discipline. And here I want to have a shameless plug a little bit. We wrote a paper about this at SC15, where we basically propose better performance reporting rules for improving the quality of papers. Okay, so then some side notes. I have 2 side notes towards the end of this quick presentation. So we all know that the time frame was too tight, so we got some complaints about this. Yes, this was basically due to the ACM process for getting the conference sponsored that took a little bit longer than we thought. We believe that the face-to-face meeting is incredibly efficient. We also believe that that our mantra, scientific quality and novelty first, may not have been the best decision, because we did a little bit unjust to experience in engineering papers. So we propose to actually introduce a special track for experience papers in the next iteration of the conference, but we will see how this goes. Conflict handling can a little bit improved. And of course, the chair load is a little bit high. As you can see, there are basically way too many meetings to plan the meeting, in fact, in front of the meeting. But yeah, so with that, I want to thank our committee. So here are all the committee members that have reviewed. As I mentioned, this is not a standing committee, so they were picked for the paper to have the best possible reviews for each of these papers, so they barely fit on this slide, but this really enabled us to get the highest quality done. We have the proceedings. If you just take a picture of this, you will get there, or you type this. If you're old school, you can remember this URL and type this down as well. And now the question is, if you have any feedback, please let me know. Please also let David know, or anybody from the organization, because we are more than willing to incorporate your feedback in the next iterations to make this process even better. And we're looking forward to a bright future and see to get more submissions next year, and in fact establish this as a new way of publications in computer science between computer science and other domain sciences. This journal versus a conference mode somewhere in the middle. Thank you very much.